Good morning, everyone. Today's topic is binary weighted resistor type digital to analog converter. So, this is one of the important method from conversion digital to analog signals. And before going to start today's topic, we are already completed analog signals and digital signals. The definition of analog signal is nothing but it will be changed continuously with respect of time. The amplitude of signal will be changed continuously with respect of time. Digital signals is nothing but it is a discrete signals. The digital signals, it contains only two values. One is a binary 1 and another one is a binary 0. The binary 1, it indicates high position and binary 0, it indicates low level. Next, in analog communication, in digital communication, noise will be less. Noise communication and noise purpose, with best one is the digital communication, or we get the perfect signal in digital signals only. The analog signal contains noisy output. So noise reducing purpose in analog communication, we are limiting the amplitude. So amplitude limitation is nothing but we are getting the unwanted signal or noise, we are getting the imperfect signal. Amplitude limitation is nothing but, whereas in digital communication the noise will be less and it will be more perfect signal compared with analog, but the cost of analog signal is less compared to digital signals. Next, there are some conversion methods from analog to digital and digital to analog. The analog to digital, digital to analog conversion is a main two methods. One is a binary weighted resistor type DAC. DAC stands for digital to analog converter. Second one is a R2 2R ladder network. R2 2R, both the resistors R and 2R we are using. So R2 2R and binary weighted, these two methods are used for converting digital signals into analog signals. DAC, digital to analog converter. The IDC is nothing but analog to digital converter methods are counter type, successive approximation. Next one is a flash type and parallel methods. The four methods are used for converting analog signal into digital signal. These two methods are binary weighted resistor and R2 2R ladder network are used for converting from digital signals to analog signals. The main advantage of digital signals is nothing but noise will be less compared with analog signal. Analog signal noise purpose, but basic communication system is the analog signal. Only noise is the disadvantage and main disadvantage of analog communication system. Next, these are already completed in previous classes only. So today I am going to explain about binary weighted resistor type digital to analog converter. Binary weighted, the name itself, it contains binary values. Binary is nothing but the values is zeros and ones only. Weighted, based on binary weights we can convert digital values into analog values. Means binary is nothing but conversion from 0 and 1 into analog value, that is nothing but it will be converted into voltage. So types of digital to analog converters are binary weighted resistor type digital to analog converter, and second one is the R2 2R ladder digital to analog converter. So first method is the first primary basic method is the binary weighted resistor type digital to analog converter. So weighted resistor, the weight is nothing but a weighted resistor digital to analog converter. It produces an analog output which is almost equals to binary, and that is nothing but which is almost equals to digital input by using of binary resistors in the inverting adder circuit. So here we are using the op-amp, adder type op-amp is used. We are giving input as a binary input. Binary input is nothing but giving the digital input. The digital input will be converted into analog output. So the digital input is almost equals to analog output by using of a weighted DAC. A weighted DAC method is used for converting binary inputs into analog outputs. Weighted DAC, digital to analog converter. Digital binary weighted input is converted into analog output. Next, here we are using the op amp. The op amp is a type of adder circuit. So op amp, it will be performing as an adder, subtractor, comparator, integrator, differentiator. These are the various applications of op amps. So here we are using adder type of op amp. In weighted resistor DAC, each digital level is converted into an equivalent analog voltage or current. So the each value is nothing but each input of each binary input is converted into it relevant analog output or equivalent analog output. That is nothing but each digital value is converted into equivalent analog voltage or analog voltage or current. The analog voltage or current is nothing but output of binary weighted DAC. The inputs is nothing but binary numbers 0 and 1. Next, binary weighted resistor type digital to analog converter. The circuit of the basic digital to analog converter using weighted resistors. The designing of circuit is nothing but it consists only resistors. In this value, the resistors in this circuit, the resistors depends on the weightage of the data bit. The name itself weights. So the resistors will be depends on the weights of binary bits. Next, in weighted resistor type digital to analog converter, each digital level is converted into its equivalent analog voltage or current. The converter is made up of 3 sections. The main 3 sections here we are using voltage switches with V reference voltage. Voltage switches with V reference. And second one is the resistive summing network. And third one is the summing amplifier. So this next, V reference is an accurate voltage. As we move from the LSB of the data to MSB of data to MSB. So here using the section, the converter is made up of 3 sections. First, voltage switches with V reference. So voltage switches V reference is nothing but here the V reference voltage. This is the V reference voltage. Here V reference voltage switches. These are the binary switches. This is the V reference voltage. And next, binary switches is nothing but these are the 4 switches S1 and S1, S2, S3 and S0. The 4 are the switches S0 to S3. S0 is the LSB switch. LSB is nothing but least significant bit. S1 next switch is S2 and the last switch is S3. S3 stands for most significant bit. So V reference input voltage. The circuit consists of V reference input voltage. Next, voltage switches with V reference is from starting LSB. LSB switch is nothing but it will be indicated by S0 switch position. Next switch is S1 and S2, S3. Next, the S0 switch is connected to I0 current, S1, I1, S2, I2, S3, I3. Next, the circuit will be, the output will be connected to op amp. Op amp inverting terminal. Op amp consists of 2 inputs. One is the inverting input and second one is the non-inverting input. Here we are giving the switches output will be connected with op amp inverting terminal only. The non-inverting terminal of op amp will be connected to ground case. Next, RF is the feedbacking resistance. Op amp feedbacking resistance is RF. The output of op amp is nothing but it is the analog type. The output, here we are taking the output. The output will be analog type. The output contains the values of voltages V out. So here we are applying the binary inputs. The binary inputs will be connected with switches. So the binary inputs are connected with reference switches. Next, the output will be connected to op-amp. The switches output will be connected to op-amp, and the op-amp output is nothing but op-amp. Here we are giving the inverting. The binary output will be given to inverting input. The inverting input of op-amp. The inverting output we are taken as a V0. V0 is the analog voltage. So we are giving the binary inputs, and the binary inputs will be converted into analog type of output. So first, the circuit contains of voltage difference. Next, resistive summing networks. These are the resistive summing networks, R, 2R, 4R, 8R. Next, summing amplifier. This is the summing amplifier, op-amp summing amplifier. And next, Vout is the output terminal of binary weighted resistor. So V reference is an accurate voltage. Next, as we move from the LSB data to MSB. So this is the LSB position, and it will be we are moving from LSB to MSB. MSB is the last bit, most significant bit. Next, 3 resistors on the summing network are binary progression. So the 3 resistors are in the summing network are weighted. Weights is nothing but R, 2R, 4R and 8R. So the switches will be connected to binary weighted resistors. The binary weighted resistors contains the values of R, 2R, 4R and 8R. Next, when all the switches are open, so all input currents are 0 and output current is 0. First condition, all the switches are open. So whenever all the switches are open, that is nothing but the input in the circuit is 0 and also output will be 0. So next, circuit operation. When the circuit working function is nothing but switch. Whenever the switch is closed, the circuit operation will be begins, or the circuit operation is starts. When all switches are closed, the current in the respective branches are I0 is equals to V reference by 8R when S0 is equals to 1. So all the switches are open and switch 1 is closed. Whenever the switch 1 is closed, that is nothing but S0. Switch 1 is nothing but the S0 is closed. The S0 is connected to here switch S0. Here switch S0 is connected to I0. Whenever S0 is closed, the I0 current is passed in the circuit. The I0 current will be connected with 8R binary weighted resistor. Whenever S1 is closed, or if at all S1 is closed, the current across S1 switch is nothing but I1. The I1 value will be depends on 4R resistor. Or if at all S2 is closed, S2 closed means the I2 current is passes to the circuit. The I2 current will be depends on the 2R resistor. If at all S3 will be closed, I3 current will be passed to the circuit. The I3 will be depends on the resistance of R. So the switches are depends on the with respect to currents across this, and also depends on the binary weighted across the switches. So first switch is nothing but if at all S0 is closed, whenever S0 is closed, the current passes through the circuit is by I0. The I0 is depends on the 8R resistance, or the binary weighted resistor is nothing but here the 8R. So the resistance positions are increases, that is nothing but here we are giving the resistive summing networks R, 2R, 4R, 8R, 16R. These are the resistive summing networks. So whenever the switch is closed, the respective current is across the switch is flowing to the circuit, and the current will be depends on the across resistor, current across the resistor. Here first switch LSB switch is nothing but whenever S0 is closed, that is nothing but the S0 position is indicating as 1. The current across the S0 switch is nothing but I0. I0 is nothing but current flowing through the circuit at switch S0 is equals to 1. So I0 is equals to V is equals to IR. I is equals to V by R. Here V is nothing but V reference voltage. First of all, we are taking the V reference voltage. This is the V reference voltage. Voltage switches with V reference. Next, V reference is the accurate voltage, and it will be moved from LSB data to MSB data. So that's why we are taking I0 is equals to V reference by 8R. Next, Similarly, if at all switch S1 is closed, that is nothing but switch S1 is closed, the current across the S1 switch is nothing but it indicated by the I1. So I1 indicating the current across switch 1. I1 is equals to V reference voltage, reference voltage into wherever we are taking I1 across S1 switch. Next, across I1 the binary weighted resistor is 4R. So I1 is equals to V reference into S1 by 4R. Next, I2. I2 is nothing but current across the switch S2. So whenever S2 is closed, the I2 current is passes to the circuit. I2 is equals to V reference into across I2 the switch is S2 and the resistor value is 2R. Next, I3 is equals to, I3 is nothing but the condition MSB switch is equals to 1, that is nothing but the most significant bit of the circuit is equals to 1. So whenever I3 is equals to 1, the current across the, whenever S3 is equals to 1, switch 3 is equals to 1, the current across the switch 3 is nothing but I3. The resistance across the I3 is equals to R, that is nothing but I3 is equals to V reference into S3 switch by R. S3 is nothing but switch 3 position, I3 is nothing but current across the switch 3, R is the binary weighted resistor. Next, the sum of all these inputs are equals to output current. So output current is depends on the total values. Here the I is depends on, here I is depends on I0, I1, I2, I3. So I is nothing but combination of I0 plus I1 plus I2 plus I3. So the total current is equals to sum of individual currents. The sum of individual currents is nothing but first I3 plus I2 plus I1 plus I0 is nothing but I3 is equals to V reference into S3 by R, I2 is equals to V reference into S2 by 2R, I1 is equals to V reference into S1 by 4R, and I0 is equals to V reference into S0 by 8R. So we are substituting the values in the equation 1, that is nothing but I3 plus I2 plus I1 plus I0 is equals to I. So we are substituting V reference by S3 by R plus V reference into S2 by 2R plus V reference into S1 by 4R plus V reference into S0 by 8R. First we are common the terms V reference by R. So the values here in next the values it contains is 1s3 plus 1s2 by 2 plus 1s1 by 4R plus 1s0 by 8. Just we are just we are output the V reference common the V reference by R. The V reference by R is the common term. So we are separating the common term here. So the common term we are separating, that is nothing but V reference by R. So the values here nothing but 1s3 plus 1s2 by 2 plus 1s1 by 4 plus 1s1 1s0 by 8. So when S0, S1, S2, S3 is equals to 1, the condition when S0, S2, S0, S1, S2, S3, all the switches are equals to 1, means all the switches are in closed condition. The value is nothing but the total current is nothing but I is equals to 1.875 into V reference by R. The only condition we are getting this output is nothing but all the switches are is equals to 1. S0, S1, S2, S3 are related to 1. Nothing but all are closed condition. If at all are open, the value output of current is 0 only. The output value of current is 0. But all the switches closed means it indicating one value. So the total current I is equals to 1.875 into V reference by R. So this we can produce 16 different output currents from 0 to 1.875 with respect to by opening and closing the switches. So here we are giving the we are taking the four switches, that is nothing but from S0 to S3. So the 4 switches will be combination with 16 possible terms, the 16 different output currents from 0 to 1.875. 0 is the lowest value. The whenever we are getting 0 is nothing but all the switches switches are open case. All the switches are closed case. We are getting the current I value is 1.875. That is nothing but maximum current. So in between 0 to 1.875 we are getting the 16 possible conditions. The 16 possible conditions contain 16 different output currents. The 16 possible conditions are depends on the switch closing and opening. That is nothing but first of all the switches are closed. Next, one switch is closed. Second, third, fourth, two switches are open. So we are taking up to 16 conditions. We know that all the switches are closed. The output current is nothing but I is equals to V reference into 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 into R. That is nothing but 1 by 2 indicating 0.5. 1 by 4 is nothing but 0.25 and 1 by 8 is nothing but 0.125. That is nothing but the total current when all the switches are closed condition. The total current I is equals to 1.875 into V reference by R. V reference is the reference voltage. Reference voltage will be supplied to this all switches and R is the resistance. So the total value current is total current is equals to 1.875 into V reference by R. Next, if you are assuming V reference is equals to 5 and R is equals to 5 kilo ohms, then I is equals to 1.875 is the maximum value. So these are the different possible conditions. Here we are taking the different possible conditions from 0, 0, 0, 0 to 1, 1, 0, 0. Next condition is 1, 1, 0, 1 and the next condition is 1, 1, 1, 0. All ones 13, 14, 15 and 16. First condition we are applying the all zeros. The binary switches all are open condition. That is nothing but S0, S1, S2, S3 all are equals to 0. The analog value output is 0 only. The analog output is 0. Next condition. First switch S0 is equals to 1 means S0 switch is closed and the remaining switches are open. Then we are getting the analog output is 0.2 and 0.2 and 0.125. Next one is next condition 0, 0, 1, 0. 0, 0, 1, 0 is nothing but we are getting the analog value is 0.4 and 0.25. Just we are substituting these values in the equation only. Next, fourth condition is 0, 0, 1, 1. That is nothing but we are getting the analog output is 0.6 and the next voltage value is 0.375. Next one is 0, 1, 0, 0. These are the different conditions. Switches, different switches working are closed or open. First, all switches are open. Second, S0 is closed. Second, third condition, S1 is closed. Fourth condition, S1, S0 is closed. In fifth condition, S2 is closed and the remaining are open. Sixth condition, S2 is closed and the S1 is open and S0 is also closed. In seventh condition, only S3 means most significant bit is open and the remaining two bits S0, S1 is closed and S0 is open. S2, S1 is closed and S0 is open. Eighth condition, S3 is equals to 0 is nothing but S3 is open. S2, S1, S0 are closed. In 10th condition, MSB is closed and the remaining bits are open. Next condition, MSB closed and LSB is closed and the remaining are open. Next condition, MSB closed, ST open, S1 closed, S0 is open. Next, S3 is closed, S2 open, S1 closed and S0 closed. Next condition, S2 is closed and next one is the open. So these are the different possible conditions in different switches. So whenever switch is closed, we are getting the value, or if at all the switches are open, it indicating 0 value. So this is the binary weighted resistor DAC. So this is nothing but we are getting the staircase output. So whenever the value is equals to 001, binary 001, the output voltage is equals to first 5 by 8, next 010 it equals to 5. Next 011 is equals to 10 by 8. Next condition, step size will be increased. 101. These are the different inputs, binary input combinations. 001, 010, 011. These are the different binary input combinations. That is nothing but different digital inputs. Different digital inputs will be converted into various type analog voltages. Next, advantages of binary network. So binary network is nothing but it contains only digital inputs and we are getting the analog output. The digital inputs is nothing but it will be depends on the switches. Whenever the switch is closed, the input current across the junction is considered, otherwise switch is open, the current is equals to 0. So advantages of binary weighted network is nothing but it is a simple construction and circuit is a simple construction, simple operation and fast conversion, easy type, simple construction. Just here we are taking the only switches and op amps. The switches will be either closed or open and it will be the switches output will be given to op amp inverting terminal and we are getting the output across the op amp. So that's why it is a simple construction and operation also simple. Total switch it will be depends on only conditions either 0 or 1, that is nothing but switch open or switch closed condition, and conversion will be easy. So conversion from digital to analog is also easy. But some disadvantages in binary weighted network. What are the disadvantages? Is nothing but cost is high because the number of bits is increased, the requirement of resistors also increase. Here we are taking the 4 switch conditions only from S0 to S3. So whenever the number of bits will be increased, the resistors also increase. So whenever the resistor is increases, the required cost is high, the resistors. Next, circuit complexity also increases. If at all number of bits are added, the circuit complexity or designing of circuit complexity is more. Next, it is impractical of the mass production of weighted resistors for converter higher number of bits because of the balance and range problems. So if at all number of bits are increased, the balance and range problems will be occurred. Next, disadvantages. When binary inputs are increases, it is not easy to maintain resistance ratio also. Next, so it will be completely depends on resistor weighted. So it's why whenever number of bits are increases, when it is not easy to maintain resistance ratio. Next one is the different current flows to the resistor, so the weightage ratings also different. Next one, very wide ranges of different values of resistors are required. For high accuracy of conversion, the values of resistance must be accurate. The range of different values of resistors are required. The different values of resistors is nothing but it take R, 2, R, 4, R, 8, R, 16, R. So it will be depends on number of bits. So wide range of different values of resistors required. For accuracy conversion, the value of resistance must be accurate. So each and every resistance have different values. So first conversion or accurate conversion purpose, resistance value also important. So we are taking the perfect resistor for conversion. Next, different current flows through the resistor, so their weightage rating also different. Next, accuracy and stability of conversion will be depends on the primary absolute accuracy of resistor and tracking of temperature, each other with temperature. So accuracy will depends on the resistor value and also it depends on the temperature. For a 10-bit converter, 10-digit converter, the small resistance value is 10 kilo ohms. The large resistance value it require 5.12 mega ohms. Mega ohms resistance is nothing but it is the high value. In across 5.12 mega ohms resistor, the current value will be very little bit. So small resistance is 10 kilo ohms, 10-bit conversion purpose, maximum resistance is 5.12. 5.12 is nothing but it is a large value. It is very difficult to maintain also. It is very difficult and expensive and stable resistance of values. Next, since R is very large, op amp bias currents gives drop with which offsets the output. So whenever R is increases, the drop is nothing but the current will be decreased. So the resistance, current and resistance are opposite terms. So whenever the resistance is large, op amp bias current it gives the drop which is required, which is nothing but offset output voltage. Next, binary weighted resistor is nothing but it is a simple analysis and it is a fast conversion method. The main disadvantages is nothing but that is the setup it requires wide range of accurate values of resistors. Wide range of resistors is nothing but the complete complete circuit, it depends on only the weight of resistors only. So the resistor weight is main important, and the accuracy of resistance also important. Weight and accuracy. Weight is nothing but depends on R resistor, 4R, 8R, 16R. Next, accuracy. Next, a 10-bit converter, a 10-bit digital to analog needs the ranging from R to 10R by 1024. That is nothing but 2 power 12. Next, requires low switch resistance in a transistors. Next, main disadvantage is nothing but it will be usually limited 8-bit resolution only. It will be depends on 8-bit resolution only. Resolution is nothing but these are the 4 important terms. Last time only we are discussed. Digital to analog conversion, the 4 important terms are resolution, monotonicity, accuracy and settling time. Resolution is nothing but 1 by 2 power n minus 1 into 100 is nothing. It is the reciprocal of number of bits. Next, there are some multiple choice questions is there. The multiple choice questions are related to digital to analog converter and binary weighted type digital to analog converter. So first question, it is nothing but what is the main disadvantage of binary weighted digital to analog converter? So the main advantage of binary weighted is nothing but it is a simple construction. Next, basic type of digital to analog converter. It requires only number of switches and also resistors only. The main disadvantage is nothing but the total circuit, it depends on the weights of resistors. If at all number of switches or number of bits are increases, it is difficult to maintain. So first, A is nothing but required wide range of resistors. Next, B is high operating frequency. C is nothing but high power consumption. D is slow switching. So the main disadvantage is nothing but just now only we had discussed, it requires wide range of resistors. That is nothing but A. So for better resolution output, the input of binary word length, the input of binary word length has to be increased and number of bit increases, the range of resistance values also increases. That is nothing but it depends on the range of resistors. Next, second question, how to overcome the limitations of binary weighted resistor type digital to analog converter? Limitations. Overcome the noise limitations, overcome the limitations of binary weighted resistor is nothing but we are using R2 to R ladder DAC or multiplying DACs, using monolithic DAC or using hybrid DAC. So another type of digital to analog converter are the problems, another type of digital to analog converter is nothing but R2 to R ladder only. So R2 to R ladder is nothing but it is a simple construction compared to binary weighted resistor, and also the maximum disadvantages will be overcome by using of R2 to R ladder network. In binary weighted resistor, the main disadvantages is depends on the binary weights of resistor. So to overcome these main disadvantage, then we are going for R2 to R ladder. That is nothing but how to overcome limitation of binary weighted resistor is nothing but by using of R2 to R ladder method only. That why? Because R2 to R ladder network is nothing but digital to analog converter is only 2 methods, binary weighted and R2 to R ladder network. Binary weighted ladder resistor have some limitations. It depends on resistance value. If number of bits will be increased, it is more difficult to maintain the circuit, or circuit complexity will be increases. Next, resistance accuracy is also important. So to overcome these limitations, then we go for R2 to R ladder network. So use of wide range of resistors in the limitation of binary weighted resistor type DAC, this can be avoided by using of R2 to R ladder DAC, where we are only 2 values of resistors are required. One is R and second one is 2R only. So wide range of resistors is the main problem. So to overcome the wide range of resistor limitation, then we go for R2 to R ladder DAC. Next question, third. Find the output voltage equation for 3-bit digital to analog converter with R and 2R resistors. That is nothing but V0 is equals to minus R by B2 by 8R plus B1 by 4R plus B0 by 2R. Next, minus RF into B2 by R plus B1 by 2R plus B0 by 4R. Next, V0 is equals to minus RF into B2 by 2R plus B1 by 4R plus B0 by 8R. or B naught by 4R plus B1 by 2R plus B2 by R is nothing but the output of possible combinations of binary input is nothing but V naught is equals to minus indicating we are giving to inverting terminal. So RF is the feedbacking resistance minus RF into B2 by 2R plus B1 by 4R plus B naught by 8R. 4R, 2R, 8R is the weights of resistors. Next, ability of analog output moves only in the direction of digital input move is known as analog output is move in the direction of digital input. This the already we are discussed in previous classes only. Definitions: resolution, monotonicity, accuracy is nothing but the output will be compared with ideal output, or settling time is nothing but it will be set, the output will be settled to plus or minus 1 by 2 of LSB of input bit, or accuracy is nothing but reciprocal of input, that is nothing but 1 by 2 power, reciprocal of number of bits is nothing but 1 by 2 power n minus 1. Monotonicity is nothing but the output moves only in the direction of digital input. So whenever the output moves only in the direction of digital input is called monotonicity, otherwise it is called non-monotonic input. The output will be decreases with increasing of digital inputs, it is called non-monotonic. The output will be constant or increases with respect of digital input, it is called monotonicity or monotono. Ability of analog output moves only in the direction of digital input is known as monotonicity. Or B is the resolution, C is the sampling rate, D is the dynamicity. The answer is monotonicity. The output will be depends on the digital, or the analog output will be moves in the direction of digital input. The analog output will be decreases with respect of digital input is called non-monotonic. So monotonicity is nothing but it is the DAC is the ability to follow the digital output to analog input. Next, which of the following binary weighted DAC? R2 2R. Next, pulse width modulation, PWM is nothing but pulse width modulation type of digital to analog converter, switched resistor digital to analog converter, sampling digital to analog converter. So binary weighted resistor will follow the R2 2R ladder network. That is nothing but to overcome the disadvantages in binary weighted resistor. Next we go for R2 2R ladder network. So the R2 2R ladder type digital to analog converter is known as binary weighted DAC, which consists of resistors arranged in a ladder formula or ladder type. So these are all today's topics. Today we are completed types of analog to digital converters. The types of main are the binary weighted and resistor type. Next, binary weighted is nothing but it will be depends on the weights of resistors. The binary inputs are depends on the weights of resistors and also switch conditions. Here we are taking the switches from S0 to S3. S0 is the least significant bit and S3 is the most significant bit, and the circuit will be different, depends on the V reference input voltage. It will be moves in the direction from LSBT to MSB, least significant to most significant. The output of switches will be connected to op-amp inverting terminal, and the non-inverting terminal of op-amp will be connected to ground case, and the output of op-amp is the analog types. Here this is the digital to analog converter. We are giving the digital inputs nothing but binary inputs, and it will be binary inputs is nothing but here the conditions of binary 1 and 0. Binary 0 is indicating switch closed, binary 1 and 0. Binary 1 indicating switch will be closed and binary 0 indicating all the switches are open. So it depends on the binary weighted inputs. Binary weighted inputs are two only, either 1 or 0. The 0 indicates all zeros are indicating no current will be flows to the circuit. If it all one value, that is nothing but if it all any one switch is closed, the current flows to the circuit is starts. So the current flowing is depends on the relevant switch condition, that is nothing but binary switch condition is nothing but here the binary inputs 1s and 0s. So it depends on the 1 and 0, and also resistance across the switches. The resistance across the switches is nothing but here the resistance is for example we are taking I0. I0 is nothing but current across the switch S0. The switch, whenever the switch S0 is closed condition, that is nothing but switch S0 indicating 1. So the current flowing through this switch S1 S0, and the value I0 is equals to V reference by 8R. So similarly we are getting the I1, I2, I3, and the total value I is equals to all combinations I1 plus I2 plus I3. So just we are substituting the values here and we are getting the final current I value. So here we are taking the 16 possible conditions. The 16 possible conditions will be depends on the 4 binary inputs. The binary inputs closed and opening time, open the case, we are getting the 16 possible outputs. So we can produce 16 different output currents from 0 to the maximum current value. Maximum is 1.875. So 0 to 1.875, V reference by opening, switching and closed. V reference by opening and closing the switches. I is equals to, the maximum current I is equals to 1.875 into V reference by R. Next, here giving the binary inputs, we are getting the analog output. Next, it is simple construction advantage, easy, flexible. Next, fast conversion. The main disadvantage is the complete circuit is depends on the switch conditions, means binary ones and zeros, and next number of resistors. So if at all the weights of resistors are increased, it is more difficult to maintain, and accuracy of resistance also important. Next, if at all higher number of bits is nothing but the tolerance and range problems will be occurred. Next, wide range of resistance is difficult to maintain. Next, to accuracy purpose also it is very difficult. Whenever number of bits is increased, it is not easy to maintain resistance ratio. For 10 digit converter, the minimum resistance value it requires 10 kilo ohms and the maximum resistance is 5.12 mega ohms. If at all resistance is increases, the current flowing through the circuit will be drops and it relates to offset output. Next, simple construction. So to avoid the problems, range problems, that is nothing but binary weighted resistors problem, then we go for R2 2R ladder network. Next session we are discussed about R2 2R ladder network. Some multiple choice questions are there. It will be related to binary weighted DAC. For what are the disadvantage? The main disadvantage is nothing but it requires wide range of resistors. So the wide range of resistors is the main disadvantage. Second one is the how to overcome the limitations is nothing but the next conversion method is R2 2R ladder. R2 2R ladder type DAC. To overcome the problems in binary weighted resistor, then we go for R2 2R ladder network. Next, the analog output which follow the input of binary is nothing but our analog output which moves in the direction of binary input is called monotonicity. Next, binary weighted type DAC is nothing but R2 2R ladder network and binary weighted. These are the two are digital to analog conversion methods. Binary weighted and R2 2R. Binary weighted is nothing but that it will be depends on the binary weights. Binary is nothing but inputs 1 and 0, and 1 and zeros will be depends on closed and open conditions. Based on closed and open conditions, the current flows to the circuit, and the current will be depends on the weights of resistors. Weights of resistors is nothing but R2, R4, R8R. Next, it consists of op amp only. Next, V reference voltage and summing resistors. The binary weights completely depends on the binary weighted resistor is nothing but the binary inputs are completely depends on the weights of resistors. So to maintain the weights of resistors is also main problem. To avoid the problems in binary weighted resistor, then we go for R2 2R ladder network. In next class, we can discuss about R2 2R ladder network. Thank you all.